I'm Archana Gupta, Assistant Professor in School of Computer Science, IMS Ghaziabad. Today I'm going to give you a lecture on multiplexers. This is a part of digital electronics and computer organization. Basically, multiplexer is used for taking the many inputs at a same time, and it takes one input one time and gives one output at a time. Multiplexer is a combinational circuit that has maximum of 2 to the power n data inputs, n selection lines, single output line. One of these data input will be connected to the output based on the value of selection lines. Since there are n selection lines and there will be 2 to the power n possible combinations of zeros and ones. So each combination will select only one data at a time. Multiplexer is also called as mux. If we are taking 4 into 1 multiplexer, there are 4 inputs and 1 output. And there are 2 selection lines, S0 and S1. The combination of S0 and S1 are 00, 01, 10 and 11. This is a truth table for that selection lines and output 00. Then if the value of S1 and S0 is 00, then output will be I0. If the selection lines having 01, then output will be I1. If selection lines having value 10, then output will be I2. If the selection lines are 11, then output will be I3. And the characteristic equation of this multiplexer is y is equals to S1 dash S0 dash I0 plus S1 dash S0 I1 plus S1 S0 dash I2 plus S1 S0 I3. This is a circuit diagram of multiplexer 4 into 1. Now 8 into 1 multiplexer is having 8 inputs and 1 output. There are selection lines, number is 3, S0, S1 and S2, and the output will be 1, and inputs are starts from I02 and goes to I7. This is a circuit diagram of 8 into 1 mux, and this is a block diagram of 8 into 1 mux. There are 3 selection lines and 8 inputs and 1 output. For making such type of circuit, we need 8 AND gate, 1 OR gate and 3 NOT gates. 3 NOT gates are taking the value of selection lines. The combinations of selection lines will start from binary number 0 to 7. This is a truth table for 8 to 1 multiplexer. If the value of S0, S1, S2 is 000, then the output will be D0. In same way, if the value of S0, S1, S2 is 001, then output will be D2. In the same way, the characteristic equation is y is equals to A dash B dash C dash D0 plus A dash B dash C D1 plus A dash B C dash D2 and so on. We can implement 8 into 1 multiplexer using 4 into 1 multiplexer. For this purpose, we need 2 multiplexers of 4 into 1 mux, and 1 multiplexer we need of 2 into 1 mux. Here we use 2 multiplexers 4 into 1 mux. The output of the 4 into 1 mux goes into 2 into 1 mux as a input. The selection lines for 4 into 1 mux is S0, S1, and the selection line for 2 into 1 mux is S2. And finally output will be Y, and the inputs are I0 to I7. The 4 input goes to the 4 into 1 mux. Now 16 into 1 mux, it is same as 8 into 1 mux, but the difference is that there is 16 input lines that starts from I0 to I15 and the output will be 1. We can implement this multiplexer with the help of 8 into 1 marks. In this diagram we have taken two 8 into 1 marks, one 8 into 1 marks taking 8 inputs. First marks is having I0 to I7 inputs. Second marks is having I8 to I15 inputs, and the output of 8 into 1 marks goes to 2 into 1 marks, and then finally we get one output. 8 into 1 marks will contain 3 selection lines S0, S1, S2, and 2 into 1 marks will contain one selection line, that is S3. So this is the total implementation of 16 into 1 marks using 8 into 1 marks. So this is the overall combination of 16 into 1 marks. Now we can implement 16 into 1 marks using 4 into 1 marks. This is a block diagram of 16 into 1 marks. In the block diagram you can see the input lines are starts from E0 to goes to E15. So there are 16 input lines and one output line, that is F. There are 4 selection lines that are A, B, C, D. This is a block diagram of 16 into 1 marks. For implementing 16 into 1 marks using 4 into 1 marks, we need 4 multiplexers, 4 into 1 or of 4 into 1. 4 into 1 marks is taking 4 inputs, each marks taking 4 inputs and gives 1 output. So in this way 4 multiplexers are giving 1 output, that becomes 4 output goes to again 1 multiplexer which is of 4 into 1 marks as an input. The output will be F. So in this way 16 inputs are going into 4 multiplexers which are of 4 into 1 marks and output will be 1. So at that time 16 inputs are going, but we are taking 1 output at a time. For this purpose we are taking 2 selection lines C and D and the another 4 into 1 marks which are taking 4 inputs from these 4 multiplexers having selection lines A and B. So in total selection lines are A, B, C, D, and the multiplexers are we are using in this implementation 5.